welcome to today's Pneumatic Conveying Roundtable. My name is Tracy Purdom, and I am the Editor-in-Chief of Chemical Processing, which is producing this event. This event is sponsored by Magnum Systems. During today's roundtable, Todd Smith and Kevin Solofra of the KSU Bulk Solids Innovation Center, as well as Brad Schultz from Magnum Systems, will discuss the most important issues affecting anyone who uses pneumatic conveying. Audience questions will be addressed by the experts throughout the program. Now, before I introduce our speakers, there are a few housekeeping issues that I'd like to review. On your screen, you should have a main section with today's slide deck, as well as a few sections below that main screen. Directly under the main slide is where you can submit a question. At any time during today's presentation, you can type your question for our presenter right here, and we'll get to your question during the Q&A. And if you're having technical problems, you can simply type in your question or concern, and one of our technical engineers will assist you. Under the Q&A section is the event's resources. Here you will find today's slide deck, as well as several additional handouts from our sponsor. We hope you take advantage of those valuable materials. This roundtable will be archived. We encourage you to direct coworkers to the recorded presentation. It will be available at chemicalprocessing.com's website. We will also send out an email with that information. And one final note, we ask that you respond to an exit survey at the end of the event. Your answers will help us to improve future events. And now I'd like to formally introduce our today's roundtable panelists. Todd Smith is Business and Strategy Manager at Kansas State University's Bulk Solids Innovation Center. Todd spent 35 years in the bulk solids industry before his role at the BSIC. He has a mechanical engineering degree from Kansas State University and has authored a book and many magazine articles and technical papers. Kevin is the lab manager for the Bulk Solids Innovation Center. He has a background ranging from research engineering with product scale-up through process, production management in various industries. From a process point of view, Kevin has dealt with all aspects of speccing raw materials through conveying materials and all the way to finished part quality analysis. And Brad is a regional sales manager at Magnum Systems, an OEM supplier of pneumatic conveying and packaging equipment. He is an experienced engineer with the ability to provide a common sense approach to design, testing, and selling of pneumatic conveying systems. He started off his career by designing and operating test facilities for some of the major manufacturers of pneumatic conveying equipment systems in the Midwest. Welcome, gentlemen. Looking forward to today's roundtable.
Great. Thank you very much. We're looking forward to it as well. Once again, my name is Kevin Solofra. I'm here with my colleague Todd and Brad. We'll be talking with them in a minute. Todd and myself, we are from the Kansas State University Bulk Solids Innovation Center. Picture the facility where we get to work and go to every day. We've got a great facility here. Just to give you a little bit of background for that. We're the only university-based research center for bulk solids in the America. We have test labs. We do a lot of training and education, webinars and roundtables like you're here today for. And we cover a lot of material properties labs and kind of everything related to the conveying and moving of bulk solids, from the raw material testing all the way up through it. So if there's any of that interests you, please feel free to contact myself or Todd when you get a chance. We'd love to talk to you about what you're doing, what problems you might be having, see if we might be able to help you out with that. So beyond that, I would like to pass this on to Todd. Let him.
Thanks, Kevin. All right. Give you my 30-second commercial. We are here at K-State Bulk Solid Center here to help industry. There's a lot of issues around bulk solid handling, conveying, storage, air filtration, and all types of processing of powders and bulk solids, and that's why we are here. Some of the services that we do is material properties testing. So a lot of companies will send us samples of their materials, and we test it for things that are properties that are relevant to storage and conveying and flow and air filtration. We offer education classes, for example, custom classes for new engineering folks, maintenance, operations, salespeople at your company. And we also like doing research and consulting projects and helping you all in industry. And to you, Brad.
Okay, thank you. Again, I'm Brad Schultz with Magnum Systems. We're based here in Kansas City. And Magnum Systems is the combined companies of Smoot Pneumatics and Taylor Products. And in 2001, a very smart guy realized that everything that went into a 50-pound bag or went into a super sack or came out of a super sack was probably pneumatically conveyable. And so these two companies came up for sale, and they were purchased and put together under the Magnum Systems umbrella. And we've been running that way since about 2001. And since this is a pneumatic conveying roundtable, pneumatic conveying is definitely something we do. We offer both dilute phase, pressure, vacuum, and pull-push systems. And dilute phase for us is probably about 80% of the business we do. And it's not necessarily because that's what we push for. It just seems like the applications that we run into, 80% of them are dilute phase type systems. And almost all of the dilute phase type systems we deal with are very closely tied to what our packaging machinery will do. The other 20% is dense phase. Now we do what's called traditional dense phase, which uses an ASME code vessel, pressure systems, but we do anywhere from 2-inch lines up to 6 inches, pretty much our standard. And we are a manufacturer of not only all of our sheet metal equipment, but we have our own machine shop that manufactures all of our rotary valves. And I didn't say airlock, and there's a reason for that. We make rotary valves, and it's not until you apply this valve does it become either a feeder or an airlock. But we offer what we call types. Our type 1 is our bread and butter cast iron. Our type 2 is an abrasion resistant. Then we have a poor man stainless, our type 3, which is a Needox coated valve, all the way up to our type 8, which is a ceramic valve for really, really abrasive situations. And I said we manufacture rotary valves. We make them all the way from a little 7-inch valve to a 30-inch rotary valve. So we cover quite a gamut of sizes. And then my last shameless plug about our packaging side. We do open mouth bag filling, bulk bag filling, valve bags, and everything from the filler all the way to the palletizer. So there, the last time we talk about packaging today. Todd?
All right. Next, we're going to do a quick survey, and then we're going to, after that, we'll jump into questions. So if you have questions for us from the audience, please go ahead and type those in. But right now, I'm sending a survey sent to you all. The survey, you need to answer that, please, and then we'll move on. The survey is, do you have particular interest in pneumatic conveying systems? So tell us what that is, whether you have a current system that needs improvement or a current system that you need to retrofit or change somewhat, or whether you're looking at a new type system or acquisition, or whether you're just interested in general knowledge. We're going to wait here for a few moments while you all answer the survey, please. And I see in the audience list, we have a few people that are just joining us, and we're doing this. We'll have 3 or 4 poll questions during this session, and this is the first one, looking for your information. Wait a couple of more seconds here. All right, keep answering that. All right, I've sent the information to you all. Looks like we have a cross-section here where some have existing system that needs have some issues and needs improvement. Some has a new system that could be needed in the future, and then several that are looking for general information. That's great. We're going to be answering questions. So please, that's next. Send us your questions, and oops, there we go. In the meantime, as you're typing in your questions, here's one that I'm going to be asking, starting with Brad, please. Brad, what do you see as the main improvements that pneumatic conveying suppliers have made in the last few years? What types of improvements? It seems to me that systems are a lot more reliable than they used to be. Why is that, and what other improvements have been made recently?
You know, they've definitely become more reliable than what they were 10, 15 years ago. Long time ago, we wouldn't sell a system or even really quote it unless we did testing. And a lot of that testing was because we just didn't have a lot of experience with the materials. And I mean, this is an industry-wide thing that the test labs were incredibly busy, and we were conveying what today we would consider a no-brainer type material. But the confidence in the designs of the systems and how you select the equipment and the features on the equipment has definitely gotten better just over time because of corporate confidence in handling the materials. And then, of course, there's the controls aspect of it. If you think about the path of controls in the last 10 years, controls has gotten so much more intelligent and so much easier to get more data from a system so that you can actually kind of look forward and predict when you're having a problem better than what we could 5-10 years ago.
Yeah, I agree. That makes sense.
No,
the components are all much better, in my opinion, all the things that are required for a pneumatic conveying system, and the application, the application knowledge is the bottleneck, but that seems to be better in some cases as well.
Yeah. And a lot of that as well falls right into the first poll that we had, where quite a percentage of people are looking at the improvements to the current system, which falls right into that for making it a better system or a new system, where they're going to be pulling all that right in there as well. So it kind of goes in right to the next question a little bit on that as well, Brad. Regulatory changes. I mean, there's a lot out there, and there's always a lot of requests for sanitary side of things or dust hazard side of things. What regulatory changes are out there that are kind of in fact impacting and pulling us forward and helping to direct where things go with projects and equipment?
Well, definitely the explosion control and explosion mitigation, it seems to be almost still a moving target. You would think that something as simple as explosion suppression and mitigation would be a pretty black and white rule. It still seems to be kind of fuzzy, but customers are starting to accept the fact that they've got to do something. And so that, it used to be kind of an uphill sell. If you would say so to, look, you guys need to do this explosion mitigation stuff. It used to be tougher. Nowadays, it's just, okay, yeah, you're right. We got to do it. So that part of it is definitely still there. There's still the rules out there, but sometimes the understanding exactly what the rules are and then comparing the different vendors of explosion mitigation stuff, apples to apples, is still a little fuzzy sometimes.
And Brad, the next question that we have is directly from the audience, and keep those questions coming, please. That's what makes this good. Is the next question is directly related to that. So, Brad, can you describe in a pneumatic conveying system, what is the risk of handling combustible dust? And just give us a little bit about how you address that.
What is the risk of it? The problem with explosion mitigation is that people tie dust collection and pneumatic conveying into the same can of worms, and really it's not, because the fuel air mixture in a pneumatic conveying system very seldom ever equals what it would be like in a dust collection system, but yet they've applied the rules the same way. And so sometimes it's hard to look at a very small filter and realize that the rules mean you got to put a gigantic explosion panel on the side, and you can't set it next to a wall unless you're 3 feet away, all these things. But it's the pneumatic conveying part of it has gotten kind of drug into that whole environment of you have to do it, and then line isolation and things like that. So to me, that has been the biggest struggle, is that the explosion suppression environment was developed around dust collectors, and yet we have to apply it to pneumatic conveying. And sometimes that's frustrating, I guess would be the right word. Did that answer your question, sir? Or?
Yeah, and which part is the greatest risk? I assume it's still the filter, the separator at the end, right?
It's always the filter, yeah. And that's because the world looks at a unit with 7 bags in it and extrapolates it out to a 144 bag unit. But yes, it's all still, but you still have to do the line isolation, which is protect it from a flame front going back down the convey line and going towards your blower.
Correct.
Right.
I would add that pneumatic conveying is one of the better solutions for a combustible material because it's all enclosed, unlike some other options in mechanical conveying where you've got dust that can escape. Pneumatic conveying has an advantage in that regard.
It has a couple of advantages in that regard, I agree. And one is it's just the filter that needs to be protected, because typically you have a rotary valve at the bottom, which is now that isolation device. And so now you only got to worry about your convey line coming in. So, yes.
Okay.
It's better than trying to protect a bucket elevator or a bunch of screws.
Yeah. Along those same lines, you talked to your dilute versus dense phase, kind of being that 80-20 split. Is there a difference between those when it comes to the combustible dust issue? Is one better or worse than the other? Or is there kind of just lumped together still, as if it's enclosed in the pipe, it's enclosed in the pipe?
In all honesty, I'm trying to think of the last time we did a dense phase system that the explosion suppression became an issue, partly because a lot of the materials that we convey in dense phase just aren't combustible materials. Now, granted, according to the government, water is a combustible material, but those numbers are so low on most of the things that are good dense phase candidates that you don't see as much that you have to do to the system to mitigate it.
I've seen some dense phase conveying of sugar, for example, and in which case, basically, I think from the combustible point of view, there's not a lot of advantage or disadvantage, dense phase or dilute phase. It's still the filter at the end that requires the devices to make it safe.
Yeah.
You agree, Brad?
I would totally agree with that, because like I said, the guy that they send out to look at the system and bless it, he doesn't know the difference.
Yeah.
So going past then, kind of moving a little bit past the combustible stuff, dust stuff, instrumentation. Obviously, there's a lot of instrumentation and data they need for that. But what about other aspects of the pneumatic conveying systems? Are there new instrumentation, or is there the whole Internet of Things is the buzzword that's out there right now, everything being controlled through the cloud and things like that? Are there anything along those lines that the customers are starting to ask about and want in their new products?
When you ask the question, are they asking about it? Not very often, but when you explain it to them and what you can do, usually it's something that we add. And some of that is being able to remote in and look at the PLCs and watch the systems run. The other one is a lot of the control systems now, we're doing a lot of data trending that we put into the control system so that the system is constantly logging data as to how it's performing. So you can go back and look a month ago, 2 months ago, and say, what was it doing then? And that really aids in troubleshooting a lot, is when you can go back. Because what I hate in the world of troubleshooting pneumatics is what I call corporate memory. which nobody can remember when the first time it had a problem. Everybody has an opinion about it, but nobody has any proof when the problem started. And so the trending of the data over a long period of time really helps with that corporate memory. You can actually go back and say, no, we started having problems in December. So
and somebody will come back and say, no, it was November.
But the trending of data and the performance of the system is really a great way to really go back and try to troubleshoot systems, because it gives you a better, because pneumatic conveying systems don't just break overnight. They wear out slowly, or components fail slowly. And that's where the trending really helps show that we're having a problem.
Hey, the next two questions are relevant for both of you guys. It's about abrasiveness. I know Kevin has done a lot of research and study comparing abrasiveness, and I know that Magnum Systems does an excellent job of handling abrasive materials. So I've got two questions here. One is, what parameters impact wear when conveying an abrasive material? So in other words, what do you have to be aware of if you're designing for an abrasive material? Brad?
Okay, I was gonna say I'll take that one.
Yeah.
I mean, obviously your first choice if you're handling an abrasive material is to go dense phase. Now, I'll follow up by saying not every material is dense phase conveyable. The material itself has to be either very permeable or very fluidizable for it to work well in dense phase. But if it does work in dense phase, abrasive materials, I mean, we convey foundry sands and things like that day in and day out in dense phase systems, and haven't wore out an elbow yet. And the big difference there is a good dense phase system, you can walk down the line faster than the material's running. And so you run sand down the line at a crawl, it's going to last a long time. You put sand in a dilute phase system that's running 40 miles an hour, and it won't make it over the weekend. So it really comes down to, when you got abrasive materials, can you go dense phase or not? And if you can, great, that's your answer. If it's dilute phase, then you got to start figuring out just how abrasive is abrasive. We do make abrasion resistant valves, but we've never made an abrasion last forever valve. And there's a lot of companies out there that have tried. It's just, you're going to have to accept the fact that you're going to wear out things, elbows and rotary valves.
Right.
Kevin?
Yeah, it kind of goes along that same line there. It's an abrasion resistance. It's not an abrasion proof. Kind of like when they have the fire clothing. It's a fire resistant material. It's never a fire proof material. An abrasion is the same way. It's very specific to the application. If it's a dense phase or if it's a dilute phase, there's a lot of different velocity behind it. It's kind of like if you have sandpaper, if you go very softly over your own skin with it, it's not going to do anything like what a dense phase would be. But if you take it and really quickly rub it against your skin, it's going to hurt more. It's going to abrade your skin that little bit more, and kind of give you some raw knuckles or something like that. So all of that type of factors come into it. So there's really no single scale or no way to measure it. It almost has to be specific to that application and that material for how it's being transported to understand how it's going to abrade. And that includes not just the material you're transporting like sand, but what you make that equipment out of, right? Because in yours, you had some ceramic line material, I believe, Brad, in your rotary valves, and you had some that were cast iron, some that were stainless steel. Your abrasion resistant was a coated version for a rotary valve. All of that comes in, and every one of those is going to go differently and abrade differently, even with the same sand that goes through that. So it becomes very application specific from that point of view.
Yeah. So a lot of people, go ahead. A long time ago, people tried to relate like the Mohs hardness scale to abrasion. And I don't think that worked very well. And the reason is particle shape has a lot to do with it. And like Kevin was saying, it's the application. The sandpaper analogy is a great analogy. And yeah, every one of our quotes, and mine and every other vendor, says the same thing. We don't warranty against a wear.
Right. So Kevin,
because it's something we can't control.
Kevin, how do you measure, or compare abrasiveness of one material to the next?
In our center here, we've kind of went and did a lot of research and looked at different types of testing. We kind of developed a test for that that's looking at it, and specifically at a low velocity of material, continually putting a abrasive material into a pinch point against a substrate of a carbon steel or a stainless steel material, and we're actually measuring the physical wear of the material that way. So it's great for that slow speed stuff. To see and compare it. But again, it's very specific to that. And it's not like we can say, oh, this material is a 1 and this material is a 7 and off we go. It's still specific for that application. But at the same time, we've also found parameters on that where, things like walnut shell, which is generally a soft material compared to a sand, but we can get more wear out of certain materials against walnut shell than we can out of sand if we use the right other parameters in terms of pressure and speed and things like that. So it really is a lot of variation in that.
Kevin, you want to go to the next poll question?
Sure, well, we can go to the next poll. This one is going to be a very easy, a quick and easy yes or no. Or a maybe, or if you're going there. I'm just kind of looking for if you're having issues or need improvement with your current pneumatic system. So a way to kind of give people a chance to say yes or no. I'll give you a little bit of a heads up. For anybody that says yes, there's going to be a follow-up question to this one to try to break it down a little bit more. And this will help guide us as we go through the next couple of questions that we're doing.
Yeah, this does help us decide which questions to pick for the audience.
Yeah, that looks like people are still not afraid of saying yes, even though there's more work to come. It's usually when people go, oh, nope, not me, not applicable. I'm done. I'm out. All right, so it's looking like we have a pretty good spread there. I'm going to go ahead and move on to the next stage here. This is going to be for the majority of those people who are saying yes. So we're going to kind of move this to the next poll. And for those of you that said yes, now we're looking for a little bit of information of what is that concern, or what are you looking to fix in that system. One of the ones here is abrasive wear. We already talked about that a little bit with that, but we'll kind of get an idea if that's of concern to some people. Just, a lot of basics that are out there: poor flow, age of equipment. That's a big one that's been coming up in industry, where blowers or rotary valves are starting to wear out, or even pipes are starting to wear, and things like that. Another one, the conveying rate. I know some have come through. It's like, hey, we had this design all along and they want 20% more out of it, but it was never designed for it. So what can we do? And things like that. So. All right. Give it another 10 or 15 seconds for people to answer, but it looks like we've got two horses in the lead, as they say. We're kind of going neck and neck for the high on this one.
A and F, neck and neck.
So we'll go ahead and get those results shared with everybody here. So yeah, the biggest one there really is that poor flow or plugging, and then that lack of experience or lack of knowledge in the system. So along those lines, we're going to kick this one back to Brad. As you're looking at pneumatic conveying and things along those lines, how many of your customers are coming in and looking at things because of poor flow or plugging, or looking for a new system, but they just don't know anything about it yet?
How often do we have them that they don't? I'm going to ask you to ask that question one more time.
Sure. with the customers and that you have, and the clientele in the industry right now, how many requests are you kind of getting from companies where they're wanting equipment, but they're just not even sure what questions to be asking or what they need? They just know they need to move from point A to point B.
More in the last 2 years than I've had in my entire life, I think.
Wow.
Because it seems like there's a big generational shift right now where I'm just not talking to guys with gray hair anymore. I'm talking to the guys that have been, hired right out of school. This is within their first 2 years on the job site, and the boss said, "Here, plop. We need this." And they're smart, intelligent guys, but they're new. They're very green, and it seems like there's a lot more green in the industry now than there was 5 years ago. So I'd say that I get a lot of calls where they really just don't even know where to start.
And none of the stuff is taught anywhere in college, is it?
What's that?
None of this technology of what we do is taught in college.
No. I mean, and once you sit down and explain and walk through the principles and stuff, they all get it. But it seems like there's that rollover of people in a lot of these plants where there's a lot of new young engineers that have been handed these projects to go do. And so it is what the environment is today. At least that's what I'm seeing. It seems like just in the last 2 years, it's really gone way up.
With that, and I don't disagree. I've kind of seen a lot of the same with the people that we've been dealing with. A lot of other people are pointing to the pandemic as the cause of that, where people have just changed or looked and things like that. Do you see anything related to that? And I know it's kind of beating a dead horse when we bring up COVID and lasting effects and all that. Did any of that really have an impact on the industry, in your opinion, for pneumatic conveying, or is it just kind of there and we've dealt with it and it's time to move on?
No, as far as I think that it's changed the way we do business, there's no doubt about that. Teams, I mean, it's amazing what you can get accomplished in a Teams meeting now that 2 years ago we were still trying to figure out how to spell Teams and get it on our computer. But it seems like now I'll make a plant visit, go through everything, and then from there till the project dies or closes is all done through Teams. So it's really made doing business quicker and more transparent, and everybody's just gotten so much more comfortable doing it. So I think the pandemic, it really hasn't changed our business and caused the food industry to go up or the foundry business to go down. Everybody's still going 90 miles an hour, but it's definitely become a different way to communicate.
Yeah. Okay. It's kind of the default method for our consulting business as well.
Yeah.
I've got a couple of technical questions I'm going to jump into. The first one is regarding dilute phase conveying. How do you choose between vacuum conveying or pressure conveying? I know there's a lot of what ifs and if thens, but what's a quick summary of that, Brad? Vacuum versus pressure.
Yeah, at the core of any dilute phase system, there's four pieces of equipment. There's a blower, a filter, a convey line, and a rotary valve. Those are the four pieces you have. And that doesn't matter whether it's pressure or it's vacuum. You still have to have those four pieces. But a vacuum system tends to work better when you have multiple pickup points and a common destination. So if you're picking up from a couple silos over there and a bulk bag unloader over there and a bag dump station, vacuum systems require less equipment to do the same job when you have multiple pickup points, common destination. Pressure systems are just the opposite. If you're coming from one place but have multiple destinations, pressure systems tend to work better because it reduces the amount of equipment you have to have. So that's usually where the great starting point is between pressure and vacuum is what does the application dictate you should start with? And a great example of that is a rail car unloading system. I mean, a rail car unloading system, you have six to 12 pickup points. and you bring it to one spot, that's your vacuum system. And then you're going from your vacuum receiver to 10 to 12 silos. So that's your pressure system. Right. It just makes sense from a equipment standpoint to do it that way.
And isn't the other big factor, if they need it like a long distance or high rate, pressure becomes more efficient. Therefore, smallish systems tend to be vacuum because that efficiency difference isn't a big deal. But if you get into long distance, high rate, then those tend to be more pressure systems.
Yeah. A pressure system can almost do twice what a vacuum system can do, assuming everything's the same. So I would agree that if you had one pickup point, one destination, vacuum would work or pressure would work, but a pressure system will be more economical because typically you'll be one line size smaller in that, so that all the equipment costs would go down. But assuming everything's equal, one pickup point, one destination, a pressure system will always win over a vacuum system. Now, distance comes into no matter really which way you're going. Distance is a factor you just have to deal with, and anytime you double the distance of a system, you cut its rate in half, or you have to double the line size you need. Mm-hmm. So we usually let distance kind of become that last criteria of sizing a system. So, but
okay. Great. I'm going to pull us back to the survey results that we see on the screen here again. The biggest result for this was poor flow and plugging. And we did get a couple of questions that came in for this. One is what controls are typical for detecting obstructions or blockages in the pneumatic conveyance system?
Your pressure gauge. Your pressure gauge on your vacuum blower or your pressure blower will tell you if you're having plugging problems. If the material's starting to sold out in the line or you're starting to get plugs, your pressure gauge will be the very first thing that'll tell you I've got a problem.
And along those same lines, have you ever seen any issues for material blockages doing more than just blocking, causing a self-heating or a smoldering or something along those lines, where it's more than just plugging the system? Other hazards that have come across with it?
I have never self-heating or smoldering. Number one, in a dilute phase system, the material is only in the line for a couple seconds if everything's working right. In a dense phase system, obviously it takes a little longer to get there. I read that question also, and I'd like to know more about the problem somebody's having, because I don't know if I completely understand the self-heating or smoldering part. To me, that sounds like a bigger problem than just a plugging in a line.
I think that question has to do with dust collection. You can have a big ductwork, and if the velocity is not correct, you can have material lying in the bottom of the line. Yeah. So I'm assuming they're talking about a dust collection system, because you're right. I agree completely. Dilute phase pneumatic conveying, you would not have that material lying in the bottom of the line.
And I guess if you do think about it from a dust collection, I have seen where a bad dust collection system was full of, the piping was full of material, and they did have a smoldering fire, and that'll smolder in that pipe for that long too. So yes, you're probably right, Todd. That's probably more of a dust collector question than it is a pneumatic conveying question.
And the especially one of the differences there is, in a pneumatic conveying system, it has a heavy duty blower with enough oomph to keep all that material, even if it starts to plug. Whereas a fan, you just got a few inches of water gauge, and if it starts to plug, well, the material just lies in the bottom.
Yeah. And I've seen some of the issues along those lines as well, when the process is at an elevated temperature as well. They're trying to get rid of some heat from the process, so you're already at that, have that potential heat source going right through the air. You're just not at that room temperature air, that slightly elevated temperature. So, kind of the next question as we go, sticking with the equipment, we talked about this a little bit, well, kind of along the edges, but how do we deal with an application that requires weight or weighing? Because that's kind of the other way to know that your process is no longer working, is you're not getting any material coming out the end, so you know that it's plugged that way. So what do you have for handling that aspect of things?
Yeah, I don't know, where that question originates, because there's nothing that measures how many pounds per minute are going down a line. There's been some attempts at some radar type units or microwave type units that can calculate how many pounds per minute are going down a line. I think that they're more or less you have flow or you don't have flow, but you're either going to have to weigh it at the beginning of the system or at the end of the system. And if Kevin's talking, I think that something's happened.
No, you're doing. It's all good. You're good.
Okay.
Yeah, I would agree. To do weighing, it has to be a batch type system, not continuous, right? And then you either weigh the material at the source as it's leaving, or you weigh the gain in weight at the destination, one or the other.
Yeah. Right.
Yeah. And that's where I would say we catch a lot of these problems with that trending data, like we talked about before, where rather than weighing it, we just know that we used to transfer, at 10 cycles an hour. Now we're only doing 5 cycles an hour. Or, we used to be able to fill that hopper in 30 minutes. Now it's taken us 40 minutes. It's not a weighing system, but it is definitely a way to know how many pounds are moving over there.
Yeah.
Hey, here's a question. Sorry, my system used to work okay, but now it keeps plugging. What could cause that, Brad?
I bet a cup of coffee on the airlock.
What about
Most of the time, it is the airlock in the system that is either wore out and it's leaking more air than it's supposed to, or you've got buildup in that valve that's causing less capacity. But I'll bet the cup of coffee that it's the airlock in the system that is not performing the way it used to. Now, that is a problem that's indicative of something that slowly happens over time versus this thing was running great for 20 years and now it doesn't yesterday. That may be a different thing. But if it's been a gradual thing where the frequency of plugging is just gradually increased over time, it's your rotary airlock.
That is same from my experience as well. Okay, we're going to go to the next last of 4 poll questions. I'm sending this survey to the audience and need you all to answer this, please. So what's the best way that you can improve or use pneumatic conveying system? What are the things that would help you all the most? Is it increased knowledge of the system for operators, employees, or is it training of new people? In other words, is it current people or is it new people that need training? Or are you looking for outsourcing improvement and figuring out, bringing some outside people in? Or is it a lot of it due to needing better maintenance and troubleshooting? So give us your inputs there, please. Waiting on a couple of more answers and then we'll send the results to you all. All right. 3, 2, 1. Interesting. We have a tie. B and C were not chosen, but in other words, it's not really new employees that need training, but it's the current ones. So that's interesting. That's telling. That's relevant to what we're talking about. And better maintenance and troubleshooting would be important as well. So So that's kind of what I would have expected. That's very, very interesting.
There's a lot there for other as well. That's kind of right up there with it too. So
yeah. Brad, here's an interesting question. You're conveying a soft material that can smear or form angel hair. What do you do about that? How do you reduce that particle damage?
I'm going to assume that this guy's talking about a soft plastic pellet.
Mm-hmm.
And the fact that it can smear a little bit. They make convey line out there that's called flow line pipe or a shot pane pipe that helps when a pellet hits the pipe, rather than it skidding along the bottom, because you got to remember it's trying to go 40 miles an hour. Rather than it skidding along the bottom and creating an angel hair, it actually hits one of those grooves and bounces up, and it eliminates the skid mark. It does create a little bit of dust. So dust is easier for equipment to handle than angel hairs are. So that technology has been around for a while. It doesn't get applied as much as it probably should. That's one way. The other way is to optimize the velocity you're moving them down the line. Most of the time, anybody sizing a plastic pellet system is going to start with a known velocity of, we'll call it 4,000 feet per minute down the line, but nobody ever adjusts that to the loading that's going down the line, because if the loading is light enough in the line, you can actually slow that velocity down to where those pellets are just rolling along the bottom of the pipe. Works fine on low rates. If you're trying to get 60,000 pounds an hour of pellets somewhere, now that's a different animal. But nobody really goes back sometimes on that type of application and really looks at the solids loading, the distance that they're going, and tries to optimize the system. I'd put the blower on a VFD and try slowing the pipe down. Would be the first thing I would do, not knowing, of course, all the parameters of this person's problem. But light loadings you can get by with a lot.
Yeah, velocity is the biggest culprit, isn't it?
Yeah.
So for another one, for some equipment side there, another question that kind of came in. Loading into a pneumatic system, conveying system, we really haven't talked much about that. A question came up is a double dump valve versus a double airlock or double rotary valve system. Which way is better, or is there reasons to use one versus the other?
You want to run with it, Kevin, or you want me to?
Oh, I was going to pass it to you first, and I can follow up after that.
Okay. Well, I mean, the question of, do you use a double dump valve or you use a rotary valve? Obviously, double dump valves have their place in the world. They're very good at abrasive materials because they don't have the tight tolerances.
Right.
The downside to them is they end up getting tall for a given rate. But double dump valves definitely have their place in the world with abrasive materials. And they work well when they're applied in the right place. They're not as forgiving as a rotary valve as far as, tweaking the rates up and down, but they do have their place. And I don't remember, did that question have a second phase to it or second part to it?
No, it was just the dump valves versus the airlocks.
Yeah.
And see, my answer with that goes with the engineering answer that I've always put out there. It's the one that I hate to hear the most, but it's always the one that makes the most sense. And you've already answered it. It depends. What is it that you're trying to do? Is it just get material in there? Are you really trying to control the rate? If you're doing a really close rate control aspect, the airlock systems might be a little bit better, where you're controlling the RPM of those airlocks going in. If you're not as concerned about that, a dump valve, it just goes in, and as fast as it can move that 50 pounds or 100 pounds as it dumps in and goes, then it can go. So that's kind of my take on that part of it, in addition to what you had there.
Yeah, rotary valves, I love this statement. A wise man once told me, he said, a rotary valve is a horrible metering device because it's not very linear, and they're a horrible airlock because they leak air, because there's that tolerances that are machined into it, but they're the only device out there that can do both at the same time reliably.
Yes.
That's a good summary.
And I look at the rotary vac not so much for controlling the throughput as much as it prevents a plug in the very beginning. A dump valve just going to, the whole cross-sectional area of your pipe is going to get plugged. Do you have enough power? And is the material, like you said earlier, permeable enough to actually move along? Or if you've got a dense material like a calcium carbonate or a titania, if you put in a dump valve and it fills the whole pipe, chances are you're done. Your pipe is plugged right there, and you're not going to move anything. So that slow addition is good.
What winding down? I'll start with you, Brad. What's the most fun or most unusual project you've worked on recently?
That's a good one. I did have an interesting one that I got called to a job site just Tuesday. Customer said he had a smoot system that was brought from another plant installed, and they've never gotten it to work right. And so I drove up there to take a look at it, and it happens to be the second system I ever sold for Magnum Systems, and it was sold into a facility. Yeah, it was sold into a facility here in Kansas City, and then shipped up to this other facility. And they tried to get it to run, and they couldn't because whoever moved it up there didn't understand its limitations. And that's really what it came down to, is they installed it with the wrong understanding of what the system could do. But I sat down in the conference room when they pulled out the drawings. I'm sitting there going, oh my God, this is a deja vu moment from 2020 or from within the first year of me working for Magnum Systems. But as far as weird materials or unique materials, that's the beauty of this job. It's every day is a new day in learning about a process or something that you had no clue about, that even existed. So I can't think of anything off the top of my head that was a unique, weird one. But other than the trip down memory lane from 22 years ago.
Were you able to use some of the same components and get it to work?
Well, what I ended up doing is I said, look, you got to understand what it was designed to do. It was a very weird. It was a central vacuum system that used a PD blower instead of a centrifugal exhauster.
Uh-huh.
And the thing that made it work was actually came from my grandparents' dairy farm. A dairy farm, when they're milking cows, doesn't know whether you're milking 1 cow or 10, but it has to maintain a certain vacuum level.
Yeah,
so I stole the idea of the valve that they had was a vacuum controller valve, and it's actually installed on this system. It says right on the side of it, Midwest Dairy Research. It's a milk barn vacuum controller that makes this PD system work. So,
very good.
So in that aspect, it was a little weird.
Kevin, anything from you on last unusual projects or material recently?
Most recently, I would say the one that's coming is there's some companies that are now starting to push their limits on what a dry bulk solid is for pneumatic conveying. And they keep pushing, it's going to the next process or coming out of a mixer, and they want to pneumatically convey to keep it contained and things like that, and trying to push percentages of moisture up to, 25, 30% in some cases. And it gets to the point that you're a slurry or an extrusion type of thing and no longer dry bulk solids, but still trying to find a way to make that work.
You're the man.
How about for you, Todd?
Yeah, I'd say how to improve conveying rate of kitty litter and how to do that without producing dust. That would be my most interesting one lately. So that's a good.
COVID has definitely caused the pet food industry, both the goes in and then the goes out part of it, to be an increased capacities. So yes.
Yes, indeed. And people are at home and they notice it's stinky and needs to be replaced too.
Yeah, that's the goes out to part of owning the pet. That.
I wish my kids realized that was the go out part. They just leave it there.
Yes, indeed.
On the note of kitty litter, was the kitty litter in an industrial setting, or was this somebody at home wondering how fast it's coming out of the litter box? Well, gentlemen, I appreciate all the time you put into this. It was great to listen to this and hear the stories that really kind of conveyed a lot of good knowledge for our audience members. Audience members, if they did not get to your question, they'll be happy to touch base with you and give you a follow-up on your questions so that you can walk away with even more knowledge. Did you like this presentation? Let us know your thoughts by answering our brief survey. That'll be posted to the screen in just a moment. Your candid answers are not only appreciated, but they do help us craft future events. Remember, this roundtable will be available on chemicalprocessing.com. We'll also send out an email with the link. Feel free to log in and view it again, or to encourage your colleagues to view it. We also hope that you'll visit chemicalprocessing.com to gain access to even more tools and resources aimed at helping you achieve success. On behalf of Todd, Kevin, and Brad, and the team at the Bulk Solids Innovation Center and the folks at Magnum Systems, thank you for your attendance, and we hope you have a great day. Thanks, gentlemen.
Thanks, everybody. Have a great day.
Thanks.
Thanks, Brad. Good job.
Catch you guys later.